All right, all right, all right, all right. Let's take a look at the current events. All right, am I back? Yeah, yeah, okay, okay. All right, let's see what we have got going here. Um, Wait a minute. What the crap? Okay, let's say fewer. Um, uh-oh, let's learn. Um, is one of them gonna be jQuery? Oh gosh. I don't know. I think jQuery is still probably good. I don't know. It's a humorous phrase, not meant literally. True, 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 true. Let's see. Let's take a quick look at what it actually said here. So the way I kind of do it is I try to keep the responses brief. So the square root phrase here has been used as a humorous way to poke fun at those who are overly serious about math. So in essence, there ain't no square root North Dakota because it's not even possible or makes sense for the reasons you know. Would love if you had another Q. And so then I say, hey, much too long, and I just say 42 characters. And then it tries to say it like much shorter, which it did a good job this time. But yeah. So that's that. Um, let's go to Advent of Cyber. Oh wait, let's find out what are the other four. Okay, so jQuery was one. Um, I would say probably Axios because fetch really is very good now. Nope. Okay, so they're saying say goodbye to moment, and why is that? It's deprecated, so date functions or Luxon. Okay, okay. So the actual native API has been evolving, so that's great. Okay, so why don't we need Lodash anymore? Probably again because the native APIs have evolved, right? Um, and underscore, same thing. All right, so then what about this one? Require JS? Okay, fair enough. Fair enough. Um, cool. Very good. That's great. All right, let's look at task 14. So let's see. So are they all green except this latest? Yeah. So this is day 8, apparently. Wild. All right, so it says shell codes of the world unite. Interesting. So each day has a different like topic, right? So one of these was OPSEC, and then there were log analysis here and here, and this was AWS log analysis. Okay, sure. This was Atomic Red Team. I do not remember why it was called that at all. What did we do on this one? Okay, yeah, so here we just like picked a vulnerability and then we ran this tool, which seems cool, I guess. No, I don't guess. I think it seems very cool. I just, it was sort of a whirlwind introduction. All right. XXE, so that was an XML vulnerability, right? So an XML, what's the second X? It's an exploit. The second X is for like an expansion, right? XML expansion? No, external entity. Okay. Sandboxes. All right, so let's just hop into here. I don't know. So it says, do I need to start the attack box today? It says check, but we can actually just use RDP. So that's, I think, easier usually. And we'll use this. So let's see what it is that we are expected to kind of try here. Generate a shell code. All right. So we generated a shell code, which looks like it's sort of a bytecode thing that has happened. So let's see. So they said MSF Venom. Okay, I'm not familiar with that at all. -p it says. Windows x64 shell reverse TCP lhost. equals attack box IP, L port equals 1111-F PowerShell. Okay, so I don't really know what we're doing. We're making some kind of binary file, I guess. Final size of PowerShell file. So what's shown here, this is nowhere near 2,000 bytes, right? Okay, so the P flag says we are creating a shell reverse TCP payload. And the reverse shell, I guess I really just don't know what it is, right? A type of connection in which the target initiates a connection back to your attacking machine. Okay, cool. Okay, so the actual shell code is this bytecode thing. Okay, so here in PowerShell, we are going to find, I guess we've got to find that binary file, right? Where is that? Right here, right? $buff is what we saved it to. Okay. And then this is going to be system runtime interrupt services Marshall. Okay. And then the address. So was the address set here? Or no? The buff was set. So we set the address where? Here? Okay, so the buff was the shellcode placeholder, which came from... So we'll have to set this shellcode placeholder, right? Or we'll have to paste it. If you're new, memorizing these functions is unnecessary. Most penetration testers use pre-made or automated tools to run a shellcode, so you don't have to know every technical detail to complete the job. No need to worry. So what are they saying? They're saying, you know, you can be a script kiddie and that's just fine. They're not really saying that. Are they? That's kind of what it sounds like they're saying here, but I'm sure that they probably will go back on that if you go a little bit later in like their courses, right? So anyway, so let's actually just walk through whatever it is that they're doing and try not to take too long. So we'll start that up, I guess. Oh no. Oh no, it's the split screen again. I hate the split screen. Okay, so we need to get on the VPN, right? It keeps doing the dang split screen, right? So this is AOC shell coding v5. So it's initializing, and so they do explain, right? Like, I think this should be pretty good stuff, right? Okay, yeah, so explanation. So allocate memory in the process address space. Okay. That's here. Let's take a look. So we're gonna do public static. Wait, so we're kind of defining it here. We're using kernel 32 DLL, I guess. Okay. So is the function body of this, let's see. So is the function body of this in the DLL? Is this how this works? It must be, right? And we just have to make sure we have a function signature for it, I guess. Call a few Windows APIs via C# code. Yeah. Wait for single object, sure. Okay, so it says connected. So now let's go ahead and open up the Remina. And then we'll find whatever it said we needed. So we'll go like this. Okay, so let's save. And let's go ahead and update resolution. Okay. Was there a like full screen? Okay, I think we're okay. So now let's go through what it says here. Okay, so we're at user's glitch, it looks like. And I don't think I have anything there. But let's see if there's a file for this code. So let's try this, MSF Venom. And it says Windows X. Did I hit caps lock? Oh, goodness. So then this says attack box IP. You will require to replace the attack box IP with the IP of the attack box. So this is in the attack box. Okay, so let's see. I guess we'll just use that, right? Huh. Okay. eb71f. Sure. And then we'll say L port equals 1111. So I'm in the wrong place, huh? So we start a virtual machine. Aside from the VM. All right, fair enough, I guess. All right, so now let's see what's going to happen. It's not going to be a second split screen, is it? Probably? Okay. Fine. Yeah, it opens the split screen on the right. I still haven't really figured out. I guess I need to figure out how to customize the layout of the page a little bit or something. Oh man, all right. Now I don't know what I'm doing. I'm sure I should read this. Let's see. Hmm. All right. So, here we go. All right. Are we able to see that kinda? I guess kinda. Oh no. Oh no, it went away. Okay. All right. Is this gonna help us? All right. Are we able to see that? Okay. All right. So we got something. Okay. Good. All right. So the shell code placeholder. Okay. Allocating memory for the shell code. Okay. All right. Sure. Okay. New window. So we're gonna try to paste this. Okay. Okay, so if we have that in the clipboard and we paste, there we go. All right, so now we just have to go to that part, the placeholder, and it says what? Okay, so we'll grab this. And I guess we have to, like, convert this back to binary, right? But I guess that's going to happen here somewhere. Shellcode placeholder. Okay, seems right, I think. So navigate to the attached VM, open PowerShell, and paste parts like this. Okay. So we'll come back here. Huh. All right. Any luck? Okay, add type. Okay, so then why did they have us do it this way? So we add this. Okay, so now this part. Copy. Okay, I guess. Let's see what it says. I don't know if that's the way to go, but we'll see. Byte array, okay. It says one line at a time, paste it and press enter, but is that really required? Let's see. I think it's fine. Uh-oh, I think I messed something up. Oh no, this is still listening. Oh wait, it stopped listening. Why did we stop listening? Oh my gosh, it worked. It is still listening. What? That's exciting. All right. Yeah, that's wild. All right, so now what are we going to do? We just want to look at a flag, right? Cat. What was it on Windows? I used to use Windows CMD quite a bit. And there was a different thing that you used instead of cat. I think it was I'd have to look it up. Oh my gosh. It's weird getting to the point where like you know that like what you've forgotten is way more than what you know. Okay. Windows CMD version of cat. Shoot. I'm gonna be like, darn, I should have remembered that. It is... Wait, where is it? Type. That's what it is. Yeah, I'm not surprised that I didn't remember that, actually. So it's type. Really? Okay. The flag may take around a minute to appear. Huh. Okay, so we're going to go to desktop. We're going to ls. So this one, so it's not ls. This one is dir. Yeah, I do remember that one. Okay, so yeah, there's nothing there. So what's the deal? What is the flag value once glitch gets reverse shell on the digital vault using port 444? Okay. I said 3 4s, but it's 4 4s. Okay. So we want to stop this and just do it again with 444. Man, even if I had read ahead, I don't know that I would have understood any of that. And then also it says okay. That is not 4. Okay, so then here. And so now we've got to edit that file again, right? The new code, I guess. Copy that. Paste here. Okay, so now we'll copy this. So copy, clipboard, come back over here, paste. Yeah. All right. And then over here, is it going to show it again? Okay, so now desktop. Okay, so now we have to put this AOC, got my access back. Isn't this is the kind of thing to get you excited, right? If I could speak. kind of think to get you excited about doing like cyber security, reverse shell stuff. I don't know. So a premium room, they got premium rooms like crazy, and why not? They got to make money. They're providing a good service, it seems like. So, all right. So we took a look and saw that it was premium. Like, I don't know. Yeah, I took a look. Sure. Okay, let's go to Advent of Code. I'm gonna take a short break. I know it's still early, but um, I'm gonna open up day 8. I'm here a little bit earlier-ish this time, so I'm gonna be right back. Uh, maybe 5 minutes, maybe. Well, I feel much better. All right. Let's see. Okay. The historians do their thing. You take a look at the familiar huge antenna. Okay. Imitation mediocre chocolate? Oh no. Okay, so the puzzle input is like this, where we have dots sort of arranged in a grid. Understandable. And then we have some zeros, okay? And then some letter A. Okay. So these two antennas create two antinodes. Okay, so the A's have the same frequency. So if we count from small a and go up 2, left 1, then we find another small a. So if we go up 2 and up left 1 again, then we should put a hash. So here, we went up 1, left 1, all right. They're both big A, so we should go up 1, left 1 again and put a hash there. And then here, we should go again. And then there's a third A, right? So from this one, we should go up 3 and over 2, okay? So we should go up 3 again, over 2 again, and put a hash, right? And then same here, we go down 3 and over 2, okay? Down 3 again, and over 2, and we should put a hash, right? Okay, so now this one. We go up 1, 2, 3, 4, and over 1, 2, 3. Okay, there it is. So we should go up again, 1, 2, 3, 4, and over 3, 1, 2, 3, and we should put a hash, right? Presumably. And then again this way, 1, 2, 3, 4, 1, 2, 3. But this time it's going to take us off the grid. All right. And then if we look at the zeros, so there's 4 of them, so there's going to be more of these. So basically the idea is this one should have a hash for each of the 3 others, and this one should have a hash for each of the 3 others, and this one should have a hash for each of the 3 others, and this one should have a hash for each of the 3 others, so 12 total, right? And so if we look at the hashes for this one, we go down 1, left 3, okay. Down 1, left 3 again, we should place 1 here, okay. Down 2, left 1, down 2, left 1. Oh, we should place 1 on that other antenna, I guess. All right, so adding a third antenna with the same frequency creates several more. All right, so when we have 2, we have a total of 2 because this one has 1 for each of the others, which there's just 1, and this one has 1 for each of the others, there's just 1, so that's 2. But now, if there's 3, this one has 1 for each of the others, this one has 1 for each of the others, and this one has 1 for each of the others, so that's 6. But we only drew 4 because if we go 1, 2, 3, 4, down 1, 1, 2, 3, 4, oh, now we're off the grid. All right. So antennas with different frequencies don't create antinodes. A and A count as different frequencies. However, antinodes can occur at locations that contain antennas. So in this diagram, the lone antenna with frequency capital A creates no antinodes, but has a lowercase a frequency antinode at its location. And so here they put hashes at all of the various antinodes that are on the grid. And so we're literally just going to count them. So yeah, so we just have to check that each one is within the bounds of the map. All right, so we'll process our input. All right, so I'm gonna say we're gonna have an input like this. All right, we're gonna split on the new lines, so we see that we have 12 lines, and then we're gonna map, and we're gonna split that on everywhere. So it's 12 by 12, we can see, I guess. So, I mean, that's good. So then also, we want to match this. So it's going to be like, and it's going to be match all. We're going to match anything that is not a literal dot. And then we're going to lazy match whatever until we find that same thing again, back reference. All right? And we can do that any number of times. Okay, so what did we look at here? So this one sort of matched these. Okay, so a literal, so this doesn't work either. Okay, that's more like it. That's more like it. Okay. So 0, 0, 0, 0, A. So that's actually no good. That doesn't make sense. So we'll get rid of the back reference. It's not working, and I can't think how to make it work. So it'll just be this. Okay, so if we have just like, we know that these are zeros, and we have their locations, and then we know that these are A's, and we have their locations, right? So input width input height equals so we won't do that just yet. So we'll say a const array input equals this, and then we'll say equals array input okay, so what's our input width? 12. So 12 by 12, right? Does it look like 12 by 12? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Does that look right? Okay, so that's fine. So then when we do these matches, so then this number should become like the coordinates, right? So this will be, we'll call it frequency. So that, yeah, the whatever that is, that indicates a frequency. And then we'll have an x coordinate, which is E index mod input width plus 1, adding 1 for the new line. Y math floor E index divide input width plus 1. Okay, so I've got frequency. Okay, so then I wanted to change this like this. Okay, so now what does it look like? So it says I've got a 0 at x8, y1. Okay, so y1 seems right. And then this is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8. So that seems right. Then we've got one at y2, x5. Okay. y3, x7. Cool. y4, x4. Great. Then we've got one at y5, x6. Okay, good. Then y8, x8. Yep. y9. See? Okay, so now let's actually solve it. So so these are going to be transmitters, right? Okay, so now let's start putting together the full solution. So solve equals I. And we are going to take that I and make this, right? So we'll do that. Probably not going to use that for much, but we do need it here, so that's cool, I guess. And then we'll do this, transmitters. Okay. And then let's see. So we'll go let sum equal 0. And then we'll go transmitters for each transmitter I. Then here we're going to go transmitters filter And so then this is going to be frequency. So let's just take frequency here. Okay. And then let's put the J here so we can filter out the original. Okay. So then once we've filtered, we'll go for each again. All right, and we'll take a matching transmitter. All right. Should we just take the... I think this is fine. Okay. So on the matching transmitter here, we don't need the frequency we already filtered, so we just need the X and Y, right? Let me change this one to T. I think that'll just make it easier for me. Okay, so now here we say, I'm going to make another function to find node, right? So find node, or rather anti-node is what they're called, right? Okay, so now whatever the difference is between x1 and x2, we need to go that far again, right? So we will return x1 plus, and this part I probably want to work out on paper real quick. So here I have an x of 8. Here I have an x of 5, I think, right? Is that what we thought it was? 8 and 5. And so then, so we went over 1, 2, 3. Then we're going to go over another 1, 2, 3. And so the expectation is that it should be 2, right? Okay, so if I'm passed in 8 and 5, then 8 minus 5 is 3. Okay, so I'm going to go x2 subtract. Yeah, I did need to work that out on paper. I don't do that much arithmetic these days. So then it's x1 minus x2. And I'm going to try this out to make sure that I think it makes sense. But the y calculation is just the same, right? Okay, so let me see here. Missing, that was here. Okay, so saved that. So let's just find these. So find antinode. So this first one is 8152. It says it's at 2, 3. Does that seem right? Yep, that is right. Okay. Let's do so that's an example going down and to the left. Let's do an example going down and to the right. So how about these two? So 8899. So it says 10, 10. Okay, easy. So how about an example going up and to the left? How about these two? So that'll be 7352. It says it's at 3, 1. So we're going to go 1, 2, 1. Yep, 3, 1. Okay, and one last example. Let's do these two going up and to the right. So that will be 4, 4, 7, 3. So that says it's 10, 2. So we'll go 1, 2, 3. 1, 2, 3. Yeah, 10, 2. Okay, so that part seems fine. So let's go back up to where we're trying to solve. Okay, so then here we'll say const antinode equals find antinode, and that's gonna be tx ty xy. Okay, and then we're gonna say if here, let's say that this is gonna be anti-x anti. So if anti-x greater than equals 0 and anti-x less than input width and anti-y greater or equal to 0 and anti-y less than input height, okay, then the sum plus plus. And then we'll return the sum. Okay, so it doesn't seem like a lot. It is the part 1. So now let's try running it. Solve. I've probably forgotten some things, but let's see what happens. So we'll pop that in there. It says 15, but no, we actually counted one that was not meant to be counted. Or made some other error. But let's just see. So in this part, okay, so we got one at 2, 3, and we'll be able to see these, right? So, okay, so 2, 3 is here. No, where is it? Here. Is that it? Or is it just not correct? 2, 3 should not be 1. I don't think. Oh no, it's this one. My bad. I was counting the wrong way. I keep doing that. Okay, 6, 5. Okay, it's this one, right? Okay, good. 0, 7 here. Okay, yeah. Okay, yeah. This is looking pretty much right, I think. 1, 2, 3, 4, 5, 6, 7. Okay, 11, 0. That's there. 9, 4. Is that this one? Yeah. 3, 6. Is that this one? Yeah. 3, 1. 1, 5. 6, 0. 10, 2. Yeah. 10, 11. Should be that one, right? And 1010 is also shown. 4, 2. So have I double counted one? I think I've double counted one. Where's 4, 2? This one. 3, 1. Is that this one? And 7, 7. Okay, and so then the total came out 15. All right, so is 1 a double counted somewhere? 3, 1. Yeah, 3, 1 appears twice. Okay, so 3, 1 is here. So we got it from these two. Did we also get it from these? 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. Okay, so we have 2 in the same spot, I guess, right? So 1, 1, 2, 1, 1, 2. Yeah, 2 in the same spot, so we're not supposed to double count, right? And yeah, so it's how many unique locations, and I think that there's a lore sort of explanation. Is it because... Wait a minute. Oh, the signal only applies its nefarious effect. Okay, so anyway, so basically we double counted. So we're just gonna have to not double count, which is, you know, easy. So when we make the sum, we will say const scene equals new set. And we can skip that. We'll say if okay, I'm gonna go back and call this anti-node again. Oh, wait a minute, wait a minute. Let's just mash them together, I guess. So I'm gonna say chord ID equals X, Y, anti-X, anti-Y, and then we'll say if chord ID, if not, there we go, scene has, okay, scene add chord. All right. Uh-oh. If, okay, is that it? So now it says 14. So yeah, so we did find that pretty significant edge case that had been missed, and they were nice by like including that in the basic input. So, do I think that there's something else important that I'm gonna find that's screwed up when I do the big input? I don't know. Let's find out. It doesn't look that huge. Let's see how this goes. I got 280. Does it seem plausible? I'm not really sure. Okay, so that was correct. So now what's part 2? Oh, I gotta sleep more and, I don't know, stretch or something. Something to keep my muscles and joints limber. All right. So watching over your shoulder as you work, one of the historians asks if you took the effects of resonant harmonics into your calculations. Uh-oh, this is going to make it trickier. Well, it sure sounds trickier. Let's see how it actually works. After updating your model, it turns out that an antinode occurs at any grid position exactly in line with at least two antennas of the same frequency, regardless of distance. This means that some of the new antinodes will occur at the position of each antenna, unless that antenna is the only one of its frequency. Okay, so now we keep counting. So this makes sense. Yeah, actually, this doesn't seem like that big of a difference. I wonder if they do deliberately choose easier ones for, like, weekends, or if I just simply haven't realized that this is going to be trickier than I thought. Okay, so if we do find antinode, find antinodes is going to be, I guess, basically like, let's see, like this. So find antinodes. So we'll still take in the, fix my desk setup, my keyboard onto there. Okay, so we'll still take x1, y1, x2, y2, I guess. All right, so now we'll say const antinodes equals this. And we'll say while x1 greater than equals 0 and x1 less than input width and y1 greater equals 0 and y1 less than input height. Okay. So then here we will say antinodes push x1, y1. No, hold on. I guess it should be x2, no. Okay, so let's just make this x, y, and then here we'll say let x equal x2. Is that where we want to start? I think so. Let y equal y2. xy. And then here we will say x minus equals x1 minus x2, y minus equals y1 minus y2. Yeah? Okay, so then here, what the heck did I just do? Did I just hit enter? I sure didn't mean to. Okay, so then here, we'll say const antinodes. All right, so this will be sum 1. So we'll do both parts. I think it's fine. Okay, I'll call this scene 1. And then scene 2. Okay. Sure. So then we have to go through all of the antinodes in order to do sum 2. So antinodes for each. And that's going to be an x and a y. So then here I will again say chord ID equals x, 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 there we go, y, y, if scene, I think my posture is even worse than usual today somehow. Okay, so so if not scene 2 has chord ID, okay. Okay, let me go ahead and put this into prettier. Oh, goodness. All right, so this is what I've got. I didn't copy it. Seems like a lot already. Okay, so let's try solving our example input. The small one. 14 and 34. So 34 is right. And like, yeah, I mean, it seems straightforward, right? It seems like really straightforward like that, I would say. So let's go ahead and do the larger. So I got 280 and 958. So, I mean, I think it seems plausible-ish. So let's put it in. And then... Okay, so that was probably the easiest one yet. That's great. So we're going to look at exorcism next. Exorcism, honestly, is easily one of the best code sites, in my opinion. I've really, really warmed to it. So, it's just, like, I feel like they've gone all out on this site in terms of just providing a lot of cool, like, stuff, support for learners, you know? Alright, I'm going to step away for a sec again. Not 5 minutes this time, like 2 minutes. Alright. So where were we? We were going to do this in Perl. Okay, okay. Okay, let's close this. We can stop the VPN. We can stop that. We can close this. Okay, cool. All right. So let's look at our file. So let's see, Perl char to int. So they do use ord. Okay. So what if we say ord student? Is that going to be possible? No tests? Hmm. All right. Okay, so I'm putting out numbers. Cool. Okay, so my n equals ord student. So why did I put a percent? Like there's specific like symbols that you use. Like I think $1 is meant to be a string. So Perl variable naming. Huh. This is the sponsor? What is this? Coding for Kids IO? I love the graphic style, right? Like they've gone for something like very familiar. Okay, okay. Huh. So get the star? Well, there you go, baby. There you go. All right, interesting. Okay, so basic syntax. So a variable name starts with $, at, or percent. A scalar is $, an array is at, a hash is percent. Okay, so we want $. Okay. Subtract 65. And then I'm going to say 2 times that, right? And then I'm going to return plants diagram n. Let's see what it complains about. Prove. No subtests run. It says, did you forget to declare my at diagram? Global symbol at diagram. Okay, so I still have that messed up. So dollar diagram here. I just have it these 2 places, right? Perl get character at string index. Looks like I've been here before, baby. So we do have to use substring. All right. And we put in the string, and then we put in so it says at plants. Okay, so Perl hash index, something like that. Okay, so we look up by saying, oh, with squiggle braces? Squiggle braces? Is this the truth? All right. So, okay, so we'll do squiggle. Prove. Okay, well, that's better. All right. So this check is sort of annoying, but okay. Array. So when we declare an array, we just use the square brackets, I think. No, we use round brackets. Okay, that's fine. Okay, so then this one will be like this. All right, and so now for this one, we have to go by the length of n, or no, the length of diagram, right? Perl string length. Looks like I've been here before as well, so we have a length function. So we're gonna go length diagram over 2 plus prove. It says what did we have happen here? Bare word result not allowed. Okay. Why does it say 8? Okay, so at plant's result is supposed to be this. Print. got 8. Are we able to see the prints? Okay, so if we want to run the file, Perl lib slash, okay, what is it going to say? So it just kind of runs. So then what about the Perl interactive? In here as well, DE. Okay, I'm not sure about that. All right. So let's see. So print at plant's result. So my expectation was that plant's result should have been an array of these different things, I guess, right? So I'm gonna say my first result, okay, my second result, my third result, my fourth result. Okay, so now then this will be first result, second result, third result, fourth result. Okay. And then can we print maybe each of these as we go? But yeah, so I don't see prints, or at least I don't think I do. Let's see. Plants in scalar context, better written as plants on 17. What did they say? Dollar plants? Oh, goodness. Okay. Is that gonna fix it? Got 4. Check array. Perl function return array. Seems like that should be okay. So I returned at plant's result, I thought. Okay, so sub plants. We did all this. Return at plant's result. So they said my at line. Shoot. Got for check array. Okay, so then here they did just do it in square brackets. So what the heck, man? What was I looking at here? Learnperl.org. Oh my gosh, this is not that good of a site. Where's the real site? Oh no. Okay, hold on. It's not Perl 101. Perl Doc. This is where we have to be. Perl Doc. Oh my goodness gracious. Okay. Okay. Well, yeah, so in the test, it looks like they're using square brackets, so I think I shall do the same and see if that's any different. Okay, so no more hints. Got one check array. Oh my goodness. Yeah, it's hard for me to understand much of this output. So really, let's see. If we should be able to call plants down here, right? So in one of these examples, this guy goes and find lines at the end, right? So if I go and plants, and then I try putting in whatever is in the test. So let's look again. Shoot, that's not it. It's with a dash, okay. Okay, so here it is. Okay, so we're gonna try calling plants, and I'm gonna try putting in VVCCGG, new line, VVCCGG, Charlie. And now I'm gonna try to Perl clover, grass, clover, clover, array. Well, shoot. Is that what was expected from that one? So it says clover, grass, clover, clover, array. Oh my goodness gracious. Huh. Okay, so let's see. Perl print array. Easy way. Purl, purl, purl. Okay, Stack Overflow it is. Print join. Okay. Okay, so messed up 29. Oh, interesting. It says just use join. Oh, okay, so I missed this here. Nope, it still just says array 0x5af96, etc. So that's not helping. So, I mean, so the array is not defined correctly, right? So let's go back to the, so I tried the square. Let's try this again. Ah, that's much nicer. Clover, grass, clover, clover. Okay. So is that the expected output? So the one I copied from was this one, but the expected was grass. It was this one, right, Charlie? So the expected was grass, 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 right? Okay, so here we've gone wrong. I have clover, grass, clover, clover, so not even close, right? Grass, 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 grass. Okay, so now let's comment the prints. Okay, so failed 17. Okay. Okay, so I want to at least see this print, I think. Okay, grass, 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 grass. Okay, so now what if I go print join that? Okay, still says grass, 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 grass. So that you would think would be okay. So now let's do several more. Put my music back on. What's it say about this one? Not available. Okay, so we're gonna go T. All right, so this one is oh. Okay. And this one. Whoops. And one more. Grass, 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 grass. Violets, radishes, violets, radishes. So these are the ones we did. Or which ones? Which ones? Was Charlie? Yeah. Grass, 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 grass. Okay. Violets, radishes, violets, radishes. Clover, grass, clover, clover. Violets, violets, clover, grass. Radishes, violets, clover, radishes. Okay. So what I've confirmed here is that the output looks right to me when I print it, but it's not coming out correctly in the test, right? It looks right when I print it, but it's not coming out looking correct in the test. So it's saying got 4, check array. I don't know why it says that. But that's what it says the same thing everywhere. Got 4, check array. So when I print it, it looks correct. So at least something is right. But I think, so somehow when we return this at plant's result, it's not doing it for us, right? Okay, so this is Perl code. So if we look at this first one, they say they call plants, and then the expected is like this, right? So, sure, so far so good, maybe? So I had to return it like this in order to make the print look okay. But let's say, what if I return it using a syntax more like what was used there? And if I just try saying this, like first result, second result, third result, fourth result. Is that possible? Okay, that was it. That was all that was needed. Let's submit. Okay, let me look and see if I want to try to refactor. First of all, let's see if this is accepted. Oh my gosh, it opened over there again. No more. So it says passed. So that's good. Okay, so let's look. So this, I'm just going to leave alone. This was already there. Okay, let's take out the prints. Okay, so this is what it looks like. I have this n first. Okay, and we're not going to use that. Okay, so now how's this? N first, second, third, fourth. Yeah, honestly, I think it's fine. I'm about 2 hours in. Okay. So let's mark this as complete. So that's good. Okay. So that still hasn't given me the greatest impression of Pearl necessarily. Like it hasn't made the greatest impression on me. I think I could learn to like it, you know, if I were to do much work with it. Okay, so this row here is close to being done, but to finish it completely, I have to finish Knapsack in Prologue and JQ, so I'm not prepared to do that yet. I'm gonna try to learn some Prologue later after doing a couple more here. So to finish this row completely, there's Prologue again. I'm still holding off on that. That one scares me the most, and JQ, honestly. So then this one, we could finish this entire row by finishing 7, and that includes 2 puzzles that I haven't looked at yet at all. And these probably shouldn't be too bad. C sharp, of course, is very nice. Kotlin is nice. Elixir is nice. I haven't finished one with Unison yet. Bash is fine. I'm not very good with Bash, but I think it's fine. 8th, I think, is fine. I think I sort of get it now after having done the first one. This one took me forever. Which one was it? This one? This one took me forever. I had no idea what was going on. And then I don't know what Ren is. So I think what I want to do now is go through and try to finish this whole row here. And let's start from left to right. So it's going to be hamming C sharp. Okay, so let's see what this one's about. Okay, Hamming, it's going to be DNA strands again, apparently. So this one comes from Rosalind. This is where, before I ever decided to become an aspiring developer, I spent quite a bit of time messing around on this site. Actually, it was with a purpose. It wasn't just hobby stuff. I was a biology student in college at the time, and I thought that doing this type of coding would be valuable if I ever ended up working in biology. In hindsight, I don't know how I ever could possibly have ended up working in biology. That's not true. I could have if I had somehow persuaded a professor to bring me on to their research team. But I'm just very unpersuasive. Like, for a normal person, persuading a professor to bring you on to their research team, from what I saw, should have been a cakewalk for, like, a person with average persuasive abilities. All right, so, we're gonna look at the Hamming distance between 2 DNA strands. All right, so basically we just want to find wherever they differ, we're just gonna count those up. So, sure, I mean, so yeah, so this is just a very, very brief little bit of code. So we'll say int sum equals 0 for... Now, do we know if they're both meant to be the same length? So let's say if first strand length less than second strand. So in that case, I think I want to switch which ones though. So I'll say return distance second strand, first strand. So swap them that way. Okay, so then sum equals first strand length minus second strand length, right? Because obviously if it overflows, then those are all different. Int I equals 0, I less than second strand length, I plus plus. If first strand sub I not equal second strand sub I sum plus plus, return sum. So we skipped 8, so let's go into the tests. Okay. Disallow empty first strand argument exception. So if for do we have is null or empty? C# string is null or empty. I think we say new here, right? Null or empty string input not allowed. That makes more sense. It's got to be a static to check that, right? Because you can't call a method on a null. 3 failed still. Oh, it was just disallow first strand longer. Oh, okay, never mind. So they do have to be the same length. Two strings of same length required. And then this one, so on empty strands, so are they actually supposed to be allowed? Okay. All right, let's mark that one as complete. Okay, let's go to the next, which is going to be 8. All right, so could be interesting. Okay, so if we try to test, what's it say? Panic expected stack depth to be 3. All right, so it's a distance between strings that are in there. All right, so now let's see. So this is an exhaustive list of built-in words. Okay. Okay, so what is 8th? Introduction, strings. So we can join where's the table of contents here? Okay, it's fine. Okay, so H2. string. All right. And we can get down there by saying, okay, so just put string here. Okay, replace, replicating, appending, removing, split, prepend, swap, okay, compare, seems like they've got a lot. What do you think? Do you think if we just put Hamming in here? Okay, so we don't have that. So structures is after strings. So it's string here and then structures. Okay, so ZT T sub trim size replace. Uh-oh, where's my music? No. Rep insert reduce norm new map. Yeah, it does seem like there's a lot. Um, I don't think anything other than strings is probably going to help much here. I don't think regex is helpful on this problem. Blob match. Mm, sure is straightforward in C sharp when you know like what's going on. Here, I think I'm gonna come back to this one. Let's look at Ren. So Ren is completely new, right? To me, I mean. Why is it? What our boot camp might be better for you? It didn't used to say this, did it? Oh my goodness. All right. Okay, let's try. Okay. All right. Great. Okay, so let's see the hello world. Could not load module. All right. And I think it'll tell us what to do in the help. Okay, so ren C. Okay. All right. So now if we do this, is that ready to go? Oh, it is. Okay, good. Great. Okay, let's see here. Okay. So now we're gonna find out about how this is. So, I mean, if it's at all close to C sharp, it should be a very quick one, I guess, to finish, right? So let's see. So we'll go ren C. And then we'll go like um, exorcism test. Looks like that's ready to go. And then in the Hamming file here, it says static compute. Okay. Sure. Okay, so ren for loop, control flow. While for, okay, so control flow, this is good. Variables. String, lovely. Great. Okay. So we're going to say var I equals 0. We're going to say while I less than, where was while again? I less than, and then on the string, we saw this. What about the length? Count. Okay. And then we'll just go like this. Easy peasy. Let's get rid of that by now. And then here, we are going to say, so here, let's say var sum equals 0. Here, let's say if first sub I not equal second sub I, sum equals sum plus 1. Okay, and then here, let's say I equals I plus 1. Okay, and then here, let's say return sum. Okay, and then let's do test. Okay, so we got a pass. Okay, so let's see what the other ones are. Okay, disallow right empty strand. Okay, so abort with. Okay, so where's abort? Fiber abort. Okay, okay. If first count not equal second count, fiber abort, string lengths must match. Test. Okay, so that only made one more pass than before. All right. No, actually they still did the same. Strands must be of equal length. I completely spaced that was what it was supposed to say. Strands must be of equal length. Okay, let's submit. All right, that wasn't too shabby. A nice, brief, very brief introduction to the Wren programming language. So let's see what it says about it on Wikipedia real quick. And then I'm just going to jump into another one. Wren. Wren programming language. So it's on Exorcism, but I don't. Okay, so small, fast, class-based concurrent scripting language. Think Smalltalk in a Lua-sized package with a dash of Erlang. Okay, okay. Well, it did seem nice. It was there. I have no complaints. It was just a really nice experience. I mean, this is just so I didn't get it to like yeah, that's one thing I would do is I would look for a command line formatter. So Wren programming language Command line source code formatter. Okay, so if we go renc help, I don't know if it doesn't need to have a formatter, but that would be one nice thing. Like, in terms of the way, like, the syntax is, I'm sure it's closer to something like C sharp, and so, I don't know, I think I like it over Lua, but it seems like it's obviously, like, not as well known, and perhaps not as mature as Lua, right? Like, Lua's been around forever, it's very widely used. But, yeah, that rend seems very nice. It seems thoughtfully made. So, let's go to... So I skipped over this because I just don't know how I'm going to do it. I'm itching to get done. Let's see, what time did I... It's 2:30 and I said I'd go till 4. Okay, well, yeah, I'll still go till 4. All right. Let's do another one. So, food chain is my least favorite puzzle out of all of the ones that I've seen so far. Okay, rotational cipher. Something about this unison makes me nervous. Should I just try it Kotlin style first? Okay. Let's see what it's about. Let's try this. I've been needing to update the colors. Like, this should be pretty easy, right? Like, literally just do this. Let's try it. This could be a big, it could be a big improvement, honestly, if I just fix the color scheme a little bit, because that color scheme, it's been ugly the whole time, but it's been bothering me increasingly. So let's go in here. Okay. Looks the same. So now we put this in the vimrc. Okay, let's see. Whoops. I don't have color anywhere, so can I just put this wherever? Put this in your vimrc. Okay. Color scheme. Darkula. Ah, okay, so now it's color schemed. Right off the bat, I'm not sure that I like it better, but I think it will. I think I will. Excuse me. My goodness. Let me look at another one that was a little bit bigger, like the something in C. How about the yeah, the kindergarten garden in C. Let me look at this one. Yes, this does look a lot better. A lot better. Cool. Okay. So that's an improvement. And that only took like in less than a minute, you know, basically. All right. So I put on the Discord that I was gonna go 12 to 4, but I